Okay, so for this one, we're assuming that the sequence x to the I, or x sub I, is arithmetic. And the question is to show that alpha to the x sub I is geometric. Okay, now the property of an arithmetic sequence is that x sub I plus 1 minus x sub I is equal to d. So there's a couple ways of doing this. First way is by directly using the property that alpha sub x plus I plus 1 minus x sub I is equal to some constant difference d. That's what it means to be an arithmetic sequence, that the difference between two consecutive members of the sequence is a constant. So therefore, if I take a look at alpha to the x plus alpha x sub I plus 1 divided by alpha to the x sub I, that will be equal to alpha to the x sub I plus d divided by alpha to the x sub I. And by the laws of exponents, this will be equal to alpha to the d, which is a common ratio. So if I take two consecutive terms in this new sequence, then the ratio of the two consecutive terms is a constant, and therefore we can conclude that alpha to the x sub I is a geometric sequence. So that's one way of doing the problem. A second way of doing the problem, which is a little bit less direct, but certainly gets the job done, would do as follows. A geometric sequence has the form that x sub I is equal to x sub 1 plus I minus 1 times a common ratio d. That's the formula for the ith term of a arithmetic sequence. So therefore, alpha to the x sub I is equal to alpha to the x sub 1 plus I minus 1 times d. And this can be written as alpha to the x sub 1 times alpha to the d raised to the I sub 1. And this has the form first term times common ratio I to the minus 1, r to the I minus 1. So that has the form of the ith term of a geometric sequence, where the first term is alpha to the x sub 1, and the common ratio once again is alpha to the d. So once again, this shows that alpha to the x sub I is a geometric sequence.